Welcome to Insight Hub, the video series dedicated to the world of data and brought to you by Miracles Data Practice.
Hi, I'm Samanvita Pudle, working as Research Associate in AI and ML in Miracle Software Systems. So today we'll be discussing about IBM Auto AI, which is a Watson machine learning service. Our agenda for today is overview of Auto AI, architecture of Auto AI, automatic model selection, model metrics, data transformations, and then followed by a live demo. So let's get started with overview of Auto AI. Auto AI is a machine learning service by IBM Watson. The Auto AI graphical tool in Watson automatically analyzes the data and generates model pipelines that are customized for your problem statement. These model pipelines are created iteratively as Auto AI analyzes your dataset and discovers data transformations, algorithms, and parameter settings that work best for your problem. Results are then displayed on the leaderboard showing the automatically generated model pipelines ranked according to your problem optimization objective. Only the datasets which are of tabular format are accepted by Auto AI. The size of the dataset should not be more than 1 GB. The service that you need for using Auto AI is Watson Machine Learning Service. So Auto AI follows a sequence of steps to build the candidate pipelines. First one is data pre-processing. Most of the datasets that we work with have some missing values, but standard machine learning algorithms work with numbers and no missing values. It applies various algorithms or estimators to analyze, clean, and prepare the given raw data for machine learning algorithms. It automatically detects and categorizes the features based on the type, such as categorical or numerical. So, depending on this categorization, it uses hyperparameter optimization to determine the best combination of strategies for missing value imputation, feature encoding, and feature scaling for your data. The next step is automatic model selection. This helps in fitting a best algorithm for your data. So for this, the user has to select a column from the dataset, which will act as a target column. So based on this, the model selection will be done. Automatic feature engineering. This helps in transforming the raw data into new features with the help of combining the old features according to the problem statement. This will be done using an algorithm that is automatically selected by the Auto AI. Hyperparameter optimization refines the best performing model pipelines from the generated machine learning pipelines. Auto AI uses a different approach to evaluate these pipelines, which will be further discussed in the coming slides. Architecture of Auto AI. As discussed, using Auto AI, one can build and deploy machine learning model with sophisticated training options. There's no coding required to build your models. Most of the work will be done by this tool. Diagram here depicts the basic architecture of Auto AI. Basic step for any machine learning model is the dataset. The dataset for this tool, as mentioned, should be of tabular format, that is .csv format. After the dataset is properly loaded, we must select the target column. In other words, we must select the column that we want our model to predict according to the problem statement. Once this is done, we'll start running our Auto AI experiment. Next step here is preparing the data. It's nothing but data pre-processing, which will be done by the Auto AI. So as discussed, it will automatically detect and categorize the features based on the data type such as categorical or numerical. Depending on this, it uses hyperparameter optimization to determine the best combination of strategies for missing value imputation, feature encoding, and feature scaling for your data. After your data is properly processed, there comes a significant step, that is automatic model selection. Depending on this, the target column, the best estimator, will be selected and will be trained. After these pipelines will be generated with the selected model types, in this step, it uses hyperparameter optimization and optimized feature engineering. Once all the pipelines are generated, we have to select the best one and deploy it for testing. This is the architecture of Auto AI. Automatic model selection. Manually, whenever we want to build a model according to a problem statement, it might be difficult for us to choose the best one, which will actually have a long process to do with. Auto AI eliminates all of this and makes the process much easier. Auto AI uses two types of models for this, which are classification and regression models. IBM has provided with a list of default algorithms, and these will be used for the model selection for both the classification and regression. Only the provided default algorithms will be used for model selection. AutoAI has come up with a solution model for the model selection called Novel Approach. This approach enables testing and ranking candidate algorithms against small subsets of the data. It gradually keeps increasing the size of the subset to arrive to the best match for the algorithms. This approach saves a lot of time without sacrificing the performance. It enables ranking a large number of candidate algorithms and selecting the best match for the data. Model metrics. Model metrics are often used to measure the quality of the machine learning model. AutoAI has provided us metrics that are available for measuring the accuracy of the pipelines during training and when scoring data. The valuable metrics in AutoAI are binary classification metrics, multi-classification metrics, regression metrics, and metrics that are used for feature importance. Metrics used by AutoAI for each model type are clearly mentioned in the given documentation. So choosing the right metric is very crucial while evaluating ML models. The generated ML pipelines will be listed in a leaderboard and will be ranked depending on the model metrics. Data transformations. So now we shall discuss feature engineering and hyperparameter optimization. So let's first see feature engineering. Sometimes our models may not perform well. This is generally because our ML models overfit and fail to generalize well to the unseen data when confronted with a large number of input features. This may result in making the model unreliable in production. Feature engineering is the process of using domain knowledge of the data to create features that make ML algorithms work. If this is done correctly, the predictive power of ML algorithms increases. So generally, this manual process is error-prone and tedious. Automatic feature engineering in AutoAI follows a unique approach that explores various feature construction choices in a structured, non-exhaustive manner, while progressively maximizing the model accuracy using reinforcement learning. This results in an optimized sequence of transformations for the data that must match the algorithms for the model selection step. There is a list of transformations used by the AutoAI for the models where the selection of which transforms to apply is done in a trial and error basis. So next is hyperparameter optimization. Before moving further, let's basically know the difference between model parameters and hyperparameters. Model parameters are the parameters in the model that must be determined using the training dataset. These are the fitted parameters. Hyperparameters are the adjustable parameters that must be tuned in order to obtain a model with optimal performance. So hyperparameters generally define higher level concepts about the model such as complexity or capacity to learn. The process of finding the most optimal hyperparameters for machine learning models is called hyperparameter optimization. So generally this is done using some familiar algorithms like grid search, Bayesian optimization, and the random search. But to make this automated, AutoAI uses a model-based derivative-free global search algorithm called RBF-opt, which is tailored for the costly machine learning model training and scoring evaluations required by hyperparameter optimization. Now, as we have seen all the basic concepts of AutoAI, let's just quickly get started with the live demo. Let's get started with our today's demo. We'll be seeing a sales forecasting model created using IBM AutoAI today. So I have already created a project and a Watson machine learning instance, which is actually required for a auto AI model to be running. So this is the project. So we need to actually add AutoAI experiment to our project to go ahead and start working with it. So you just have to click on add to project and select the AutoAI experiment here. You need to give a name to the experiment and select the Watson machine learning instance there. Once you do that, your experiment will be created, and then you should go ahead and give the data set either from the project or from your local system. Once you do that, according to the target column or the target feature that you have selected, AutoAI will directly, select the model type and give you. So this is the model of regression type. So you can go ahead and select the number of algorithms that you require for your auto AI model. You can select from 1 to 4. I've selected for 4 algorithms, and as you can see, for every algorithm you have 4 different pipelines that are created. So depending on the problem type on the data set that you have, you can just go ahead and select the algorithm, and you can also edit your experiment settings according to your problem and according to your data set. Basically it's all according to your requirement. The good thing about this is that you just have to don't code anything. Everything auto AI will be taken care of. So this is the pipeline leaderboard, where you have different pipelines that are ranked according to the metric. So we have so as this is a regression model, we have root mean square error. So the less it is, the more powerful the model is. So pipeline 4 has the less RMSE, and it is of gradient boosting regressor type. So we can just click on the pipeline and see its details. You can actually go ahead and see details for every pipeline, and these are the model evaluation measures. And you can go ahead and see the model information, which basically consists of your target column, features, and the creation time. Feature transformations will help giving you information what type of different transformation techniques that are applied to the original features to create the new features. And this gives you the feature importance, how much feature is contributing to the creation. And once you can actually retrieve the information like this, and you can go ahead and evaluate. This gives you the comparison of different pipelines that are created or generated. Yeah, you can go ahead and check your relationship map here, and you can also view your full logs here, and you can download them if you require. Once you are perfectly satisfied with the pipeline and the model that you got it, you can just go ahead and save the model either as the notebook, or save it as a persistent model. So I already saved it as a model, and if you want to go ahead and make some changes, you can absolutely do them by saving it as a notebook. So even in the notebook, you can actually save it either as a auto AI notebook or your Watson Studio notebook. That's up to your choice. So once your model is persisted like this properly, you just have to click on this and go ahead and deploy it. So I already have made the deployment. So once your deployment is completely ready and perfect, you can just go ahead and test it. You just have to click there, and this is all your deployment details that you have here. So this is about your implementation, how you can actually implement this using different languages, and you have the code snippets for every language that is supported, and you just have to copy paste this in the application that you require, and you can just go ahead and utilize it. Otherwise, you can also test it online. So basically, if you have deployed it as a web service, right? So you can just give the values over here, enter the input data from your, like, enter the required data, and just you have to hit the predict button. So I already have the data that I entered here from the test data set. So I'll just go ahead and show you the test data set. So basically, for this particular model, we are trying to predict the outlet sales for the particular items. We have different features that we are utilizing here. Actually, we have MRP of the particular item. We have the outlet type. We have the outlet location. The major features that we are using to build the model. And using all those features, by giving the input schema, we have to predict the item outlet sales here. So basically, I have used the first record, and I will be going ahead and testing. So these values I've already entered. You just have to copy paste them and just click on predict. And see, you got the value here. This is my prediction, 1697, which is very much close to the value that I have. So this is how we can just go ahead and test, and otherwise you can also give it in the form of JSON format. You can do it in either ways and test your model. So basically, for testing or utilizing in the model, you should make sure that your model is persisted and deployed. Thank you so much.
Thank you for watching a video on Insight Hub. The video series brought to you by Miracles Data Practice. For more videos, please visit miraclesoft.com/insighthub.